Let us continue with chapter 8, trigonometric, exercise 8D, question number 22. We have the quantity here in the left hand side. We need to prove that it is equal to 1 plus sine theta by 1 minus sine theta. Here we have only two quantities, whereas here we have three quantities. So in order to convert this 3 to this 1, since here we have sine, we will divide each and every part here with cos, because we want plus sign here in the numerator and minus down. So we can divide each and every part by cos theta, both numerator and denominator of left hand side. So it will be 1 by cos theta plus cos divided by cos theta. Numerator, they come from the question. Cos theta we have to make up from our mind. Then sin theta by cos theta. Denominator also same. So that if we cancel cos theta, we get the original equation. 1 by cos plus cos by cos minus sin by cos. So 1 by cos, we know it is equal to sec theta. Cos by cos equal 1. Sin by cos relation, we have tan theta. Then square, we should not forget, okay? We should write whole square. Then denominator also 1 by cos, we know sec theta. Cos by cos 1. Sin theta by cos theta, we have tan theta. We don't want three quantities, we want only two. So we'll try to reduce them. If you remember from identity 2, we have sec square theta minus tan square theta equal 1. So let's sec theta plus tan theta write it one side. Then instead of 1, we will introduce with the identities which is related to sec and tan. That is the second identity. In place of 1, we can write sec square theta minus tan square theta, because this value itself is equal to 1. And the denominator, leave it like that. Then these two, we can group them together. Here now we can apply a square minus b square, which is equal to a minus b, a plus b. Then denominator, leave it as it is. Here if you compare, we have sec theta plus tan theta. Here also we have sec theta plus tan theta. So these two we can take common. So if we take them common, this side we are left with nothing. So we are write 1, because sec theta plus tan theta, here definitely 1 will be there. Then plus sec theta minus tan theta. We can write it that way. Then if we compare now, here we have plus 1, sec theta with plus, sec theta with plus, tan theta with minus, tan theta with minus. So this part and this part we can cancel. So we are left with sec theta plus tan theta. We have the square. In the right hand side, we want sine and cos. So let's convert back the using relation to sine and cos. So sec theta we have 1 by cos. Tan theta we know it is sine by cos. Since we have fraction, we can find LCM. Both the denominator are same, so we can take only 1. Numerator remain the same. 1 plus sine, we already get it, so no need to convert. We can break the bracket into two parts, numerator and denominator. In the denominator, we don't want cos. We want 1 minus sine. So we convert using identity. Cos square theta, we know it is equal to 1 minus sine square theta from identity. Then here it is whole square, so both we can write separately, plus plus. Then here we have 1 minus sine square, we can apply a square minus b square, which is equal to a minus b, a plus b. So one of the plus sign we can cancel. We are left with 1 plus sine theta, 1 minus sine theta, which is equal to right hand side. Then we continue to the next one. That is 21, number 1. We have this one, then we have to produce this. So here we can apply. We have 1 to 3 quantity whole square. We have the formula a minus b plus c whole square. which we can write as a square plus b square plus c square minus, because here we have minus, here plus 2ab. This is minus, this is plus, minus into plus, minus 2bc, then c plus a plus 2ca. Our a will be 1, our b sin theta, our c cos theta. So we replace it here. Okay, a square plus b square plus c square. Next will come 2ab. That means 2 into 1 into sine. We have 2 sine theta. 2 into sine into cos. We can write 2 sine cos theta. Then 2 into 1 into cos theta. 2 cos theta. So if you compare, here we have minus 2 sine theta cos theta. Okay, it's alone, leave it there. Here we have 1 into 1, 1. Here sine square plus cos square, from identity we know it is equal to 1. Then we write all those as usual. Here we want 2 separately, 1 plus cos separately, 1 minus sine. So now 1 plus 1, 2. 2 we have everywhere, so we can take common 2. Then we take common 2 here, so 2 into what will be 2? 2 into 1. Here we are left with sine theta. Then there you see cos theta is with plus. So let us write first cos. Okay, we just rearrange it here. Then now we have 1 minus sine theta. Leave it with. There we have cos, cos. So we can take common cos theta. This side nothing left, so we write 1. This side we finish to take cos. We are left with sine. Now if you compare 1 minus sine, 1 minus sine, we can take it. So this side we are left with 1. Then this side we have cos theta. So we get the right hand side. We'll proceed next to number 21(2). We have cosec theta minus cot theta whole square. We want cos. So we will use their relation. We know cosec equal 1 by sine. Cot is cos by sine. We can take LCM. So both are same. Okay. Then in the right hand side we want cos. So we separate the square. Then from identity, sine square theta equal 1 minus cos theta. Numerator, if we compare to the right hand side, is already there. No need to change it. But here we have a minus b whole square. So we can write a minus b, a plus b. Here, since it is whole square, we can write 2 same quantity. Then these 2 get cancelled. We are left with this, which is equal to right hand side. Then next, continue to 22. We have this one. We want only cot theta. 1 plus cos theta, we cannot do anything. But in the right hand side, we want only cot theta. We want to remove 1 plus cos. So for the time being, let it be this one. Then sine square theta, we have identity. We can write it as 1 minus cos square theta. Since we have minus, let's put it inside bracket. Then down we have 1 plus cos theta. So this 2 we can group it. Here now we can apply a square minus b square. So it become 1 minus cos, 1 plus cos. 1 plus cos, 1 plus cos. We have both sides. Take common it. Then from here, we take everything. So we are left with 1. Then minus with the second one. So here we multiply now. Okay. 1 plus cos, 1 plus cos. We can cancel. Here minus to plus minus. Minus to minus plus. So 1 minus 1, 0. We are left cos theta by sin theta. Cos theta by sin theta, we know from the relation it is equal to cot theta, and cot theta is nothing but is equal to right hand side. So let us see with 22 number 2. We have sin theta, cos theta, cos theta. So let's take common sin, sin. Let's take common cos, cos. So if you take common sin, here we are left with 1 minus. Here there are 3. 1 we take common. We are left with 2. Here also we take common cos, cos. So this side we are left 2. This side we are left with 1. Okay. So sin by cos, from the relation we can write it tan. Then in the right hand side we want only tan theta. So let's try to remove one of this. So from identity, sin square theta, we know it is 1 minus cos square theta. Denominator no need to change because we see cos square theta is coming here. So 1 minus 2 into 1, 2 minus 2 minus plus 2 cos square theta. So 2 minus 1, it will be 1. 2 is greater, minus 1. So we can rearrange them. 2 cos square theta minus 1. These two quantities are same. We cancel, we get the right hand side. Moving on to 23 number 1. 1 minus tan square theta by 1 plus tan square theta. We want cos square minus sine square. Here we have 1 plus tan square. If you remember from identity, it's equal to sec square theta. We want cos and sine. So let's break this one. 1 by sine sec square theta, break the LCM, minus tan square theta by sec square theta. 1 by sec square theta, from the relation we know it is cos square theta. Tan square theta, we can convert it, sine square by cos square. Sec square theta, we convert 1 by cos square. Cos get cancelled. We are left with sine square theta, which is equal to right hand side. Then this one we have 1 minus tan square, cos square minus 1. We want only tan square. So numerator, leave it as it is. Cos square using the relation, we know it is 1 by tan square. So here we have fraction, we take LCM. Tan square and 1 will be tan square. So we are left with 1 minus tan square theta. So there, 1 minus tan square theta, 1 minus tan square theta, we can cancel. We are left with tan square theta.